Hello everyone, welcome to the new lecture series of operating system. In today's session, we are continue with the topic Introduction to Operating System. Myself Kunal Panchal, your instructor. In today's session, we are going to discuss the concept of spooling. So we are continue with the evolution of operating system, in which second evolution of operating system is nothing but spooling. In previous session, we understood the concept of batch operating system. That was the first evolution of operating system, and spooling is nothing but second evolution of operating system. So in the batch operating system, there are certain limitations, in which the major limitation was CPU utilization is very poor when we are dealing with batch operating system, and that we are going to overcome with the help of spooling. So let us discuss spooling in detail with its advantages and disadvantages. So first of all, before going to discuss the concept of spooling, spooling stands for what? So spooling stands for simultaneous peripheral operations online. Means simultaneous means at the same time, you know very well. Peripheral operations means input output operations, and online means without intervention of IO devices. IO device operations can be performed without intervention or without involving the CPU, without involving the main memory. So that is the reason why it is called online. Okay, so intervention of CPU is not required to perform IO operation. Okay, so that is the reason why it is called online. So spooling stands for simultaneous peripheral operations online. Now let us discuss the working of spooling with the help of this diagram. Okay, in this particular diagram, in batch operating system, the computer system is mainly consists of two components that we have seen. One is CPU and second one is memory. But in this case, the computer system is categorized into two different type of memory. Means we are going to use the concept of memory hierarchy in this case. What it means? So definitely CPU is there as a core component of computer system, and memory is categorized into two subcategories. One is main memory and second one is secondary memory. So main memory is nothing but RAM and ROM, and secondary memory is nothing but hard disk. Okay, you can see the disk is nothing but secondary memory and RAM is nothing but, or you can say ROM is nothing but main memory. So the computer system in this case, the core component, or you can say main component of computer system is nothing but CPU plus main memory. Okay. Why we have introduced one special type of memory which is called secondary memory. Okay, so that I will tell you the significance, and we can say advantage to introduce this another type of memory which is nothing but secondary memory in this particular architecture. Okay, in this case, in this particular architecture of this block diagram, we have the input device and another one is output device. So how this system works actually? So in the batch operating system, what was happening when suppose particular job if you want to execute in the CPU, so until unless CPU completes that execution of the whole job, CPU cannot execute or CPU cannot deal with another process. Means it strictly following one after another in terms of process execution, in terms of job execution, we can say. Yes, and we are dealing with the card readers and punch cards and all. Okay, as far as input devices and output devices are concerned. So definitely the IO devices are slower in terms of speed as compared to the digital devices like CPU, main memory, secondary memory. So these things you have to keep in your mind. So these input output devices are not compatible with CPU, main memory and secondary memory, which are digital devices in terms of speed. So they are not compatible with each other in terms of speed. Means these IO devices are very slow and these digital devices are very fast in terms of execution. So that is the reason why if you want to deal with input output devices, definitely you did not involve the CPU for its execution. And if you avoid CPU for having the getting the input and then it will process by the CPU and then again it will be the CPU will send a response or we say output to output devices. If you that was the scenario of batch operating system, that is the reason why it is very slow and utilization of CPU is very poor because CPU requires very few amount of time to execute any task, but to have that input and produce the output, these IO devices require more time for execution. So that's why we cannot execute more and more number of processes in per unit time. Okay, so that was the limitation. So to avoid this problem, what we need to do is we need to utilize the CPU as much as we can. So by having this concept, what we can do in the case of schooling, first of all, we need to know the working of CPU speed. So CPU, you can imagine, suppose if you have a laptop or a desktop of 2.3 gigahertz processor. Okay, so do you know how much speed it contains or how much speed through which it can execute the available task? Like if you have 2.3 gigahertz processor, so definitely gigahertz is what 10 raised to power 9. So if you want to convert into a hertz, hertz is nothing but unit of frequency. So per unit time in a single second, how much clock cycles will be there in the case of 2.3 gigahertz. So if you convert these 2.3 gigahertz into hertz, so to around 30 crores hertz would be there. Means these many clock cycles would be performed in a single second. So you can imagine the power of CPU. There is enormous speed of CPU. And still people are saying my laptop or my desktop is slow nowadays. Okay, so that things you have to keep in your mind. So CPU has enormous speed, but input output devices are very slow as compared to these digital devices that we have. Okay, so by having this consideration, the spooling technique, or this is spooling, works in this way. Like, say for example, as far as input device is concerned, say for example, keyboard we have, for example. So, how many letters you can type in 1 second? CPU can have this much speed in 1 second. Yes, but if you compare the CPU speed with the keyboard speed, suppose how much? Say for example, in the case of IO devices or say input devices like keyboard, so how many letters you can type? Maximum in 1 second, maximum three to four, not more than that. And CPU can perform a task in this particular speed in a single second. So that's why these two devices are not compatible. So what we will do, once you introduce the input with the help of input device, that input data will be stored. So that first arrow, it means what, that is nothing but our first step. So what we'll do in first step, the user will introduce the input, and that input data will be stored in the secondary memory. These things you have to keep in your mind. Size of secondary memory is very much large as compared to main memory. You can say that the secondary memory is nothing but one type of go down, and main memory, you can say that is one small shop. Okay, if you're talking about if you talk about your real life situation, so main memory is small shop, and disk is nothing but large go down we have. Okay, so you can adjust more number of data in the case of secondary memory as compared to main memory. Okay, so these input data will be stored in the secondary memory first. Now what second step we will do, if you want to execute that data in the CPU, the secondary memory will give that data to main memory first, and because you know very well CPU cannot directly deal with secondary memory, CPU can directly deal with main memory only. Means CPU can execute the process or can say program when it resides in main memory only. So once we have that data will be shifted from secondary memory to main memory. That is the second step. Third step, once it resides in main memory, in third step CPU will execute that process of this data, okay, in it. Now once execution is completed, now in the fourth step, the data will be again transmitted from main memory to a secondary memory. Okay, whatever the output is generated by the CPU, computation performed by the CPU, that will be stored again in secondary memory. Okay, in the case of fourth step. And fifth step, with the help of secondary memory, that output will be given to the output device. So in this way, spooling works. So there is one advantage. We have isolated the input-output devices with CPU. Yes, so definitely CPU. The task of CPU in this case is not dependent on the input-output devices. Yes, because input and output here we have isolated from the CPU. So CPU is not dealing with input devices as well as output devices in this case. Yes, so dependency of incompatible devices are reduced in this case. Okay, and the communication between main memory and secondary memory are very fast as compared to dealing with input-output devices. Why? Because main memory and secondary memory are nothing but digital devices. Okay, And still, if you want to increase the utilization of CPU, what we can do is instead of having single input device, we can have more than one input devices, and simultaneously we are storing the input into the secondary memory, and according to that it will be shifted to a main memory and executed in the CPU and so on. So what we can do is we can utilize the CPU as much as we can when we have more than one input devices. Okay, so this is possible in the case of spooling. So we can utilize the CPU power more as compared to batch operating system in this case. Okay, so let us discuss whatever we have discussed in the case of block diagram of this architecture. That same stuff we are going to discuss over here. So input and output devices are relatively slow compared to CPU because CPU is digital device that I already told you. Okay. In spooling, data is stored first onto the disk and then CPU interact with the disk via main memory. Again, this is already explained by me in the previous slide. Okay. So keyboard, mouse, printers are input-output devices that you know very well. Okay. And spooling is capable of overlapping I/O operations for one job with CPU operation of other job. That is possible, and that I already explained. If you want to make a CPU as much as busy, what we can do is we can have a set of input devices. Okay, and those input devices we can introduce the input simultaneously and store the input data into a secondary memory so that there are less chance to the chance for CPU to idle. Okay, so once you understand this concept of spooling, now we are going to discuss the advantages and disadvantages of spooling. So the main advantage of spooling is there is no interaction of I/O operation, I/O and input and output devices with CPU. That I already explained you. There is a main advantage. Because of this point, we are getting higher speed for execution and we are getting more CPU utilization. Okay. Second advantage is CPU utilization is more as CPU is busy most of the time. Yes. So the first point is relevant with the second point. Okay. So these are the main advantages of spooling. Now what are the disadvantages? So as far as disadvantages is concerned, again, by having uniprocessor machine, okay, we cannot execute more than one task at a time, definitely. But in this case, we cannot achieve the advantage of multi-programming or multitasking operating system that we are going to discuss in upcoming session. That advantage we cannot have, okay, in spooling, because in this case, once a particular process is started its execution, and if it requires some I/O operation or any other event for its execution, definitely that at that time CPU would be idle. Okay, CPU will wait to get back that process, okay, into it, and again it will resume its execution and complete the task and then fetch the other process from the main memory. Means in this case there is a one main disadvantage is what? Because we are dealing with uniprocessor machine, and the mechanism of because of this mechanism of spooling, still we cannot able to execute a different processes, okay, simultaneously. Why? This context switching cannot be possible, or we say forceful prevention cannot be possible in the case of schooling. So, if any process during its execution, if it requires some other operations at that point of time, CPU would be idle. So that time we cannot utilize. Okay. So this was the main disadvantage of spooling. So this is all about spooling, in which we have discussed the working of spooling and pros and cons of it. Now in the next session we are going to discuss multi-programming operating system, in which we can avoid these disadvantages that we have in spooling. So I hope whatever we have discussed, it was clear to you. Thanks for watching this video. See you in the next one.